Yes, wonderful. Okay, so a quick introduction. I guess I'm lucky because I get to be the person who chooses all the different topics, because that's what happens when you create the program. And this is a pet interest of mine. And I know that the moment I thought of having vaccination and all of the quandaries that we all face and the questions that we all face when we think about vaccinating our children, the first person that I thought of is Ilana, who happens to be quite well versed in this topic, and also quite passionate about this topic. But in terms of your actual your history, I suppose, your experience in this. Ilana's the head of biology at Hasmonean High School, and you've been at Hasmonean for a decade at least, no?
Yeah, for my sins.
Yeah, so you went straight into teaching biology after Manchester University.
I did. I'd spent a couple of years in STEM and having 1 or 2 kids, and then
just 1 or 2.
The other 2 I did during the teaching.
Right. So, but your BSc is in pharmacology, and you've lectured extensively on psychological barriers to science. And I know that this is a pet passion of yours. So I'm going to hand over now. Any further introduction that you'd like to do on your qualifications or your positions on this, please feel free to do so. We are live on YouTube, so.
Okay, thank you so much, Shoshana. So yeah, as she said, I did my BSc in pharmacology. Sorry? Yes, please, thank you. Could shut it, the door. Shall I shut this door? You could tell me. Just shut the Shoshana, both of us struggling, both of us. So I did my bachelor's in pharmacology, and went pretty soon into teaching biology. And I've obviously, as a parent myself, I started out when my first child was nearly in the womb on a parenting forum called Baby Centre, which is a pretty much awful place when it comes to any sort of support you think women are going to give each other. Like you complain about having to put your dummy in a child, and someone reports you to the mod for putting a dummy in a child because it prevents them from learning how to speak. This is the kind of, you think that the internet's bad now. Gosh, Baby Centre was a absolute minefield. Over the years, just became more and more versed in it. And then started lecturing because I find particularly interesting the psychology behind this, I would say, science skepticism, vaccine hesitancy. Those are the words that I would use, which has now sort of morphed. We were seeing things happening about 20, 30 years ago in quite increasing on and off. The 90s, I think there was an outbreak of illness as a result of a whooping cough vaccine bad batch, and that really caused a big drop in whooping cough vaccination. And then, of course, the whole Wakefield thing with the MMR, I think it was in 93, which also, got massively overblown by the press. And every time they put up a headline saying that MMR doesn't cause autism, more people stopped vaccinating their children because they were scared that it did. So, there's been a lot of history in this whole area. And that's where, I really started to look to start to help people understand the science behind vaccination, to try to alleviate those fears, and also to really feel bad because it's people in my profession who must have done such a terrible job for us to get to where we are, where the understanding of science has really dropped. And it's not, to be fair, just my fault. A lot of the people who are now choosing whether, making decisions about vaccinating themselves or their children didn't have antibody-antigen relationships taught to them in biology GCSE. It might not have been on their GCSE or their O-level equivalents. The science has been, the biology curriculum, as I say, is the one that changes faster than anything else. So it is, you may just not have been taught it. So I'm just gonna see if I can share the PowerPoint just a second. It's being quite slow. Now it's saying my screen share is paused. Why is it saying that? Come on, hurry up. Okay, are you seeing the PowerPoint? Yes, excellent. Okay, so we're going to have to deal with some myths and facts that comes up quite a lot, and some of them are really quite endemic. I'm going to stick in loads of amusing memes. This is partly to make you smile, and partly because we want to deal with the misconceptions of those memes, and really explain them. So yeah, so this is the first one. This is your liver. It helps your body get rid of toxins, and this is a detox. And this concept that, you know, oh, we've got to go on a January detox. I mean, the word detox, I can't even tell you how many times I see it come up on my stream. And I'm not even talking about all my friends who are now using herbal supplements to help them lose weight, and as part of their, you know, drinking alkaline things and having lemon water, which of course is acids neutralize alkalis. So if you have an alkaline diet but you're drinking lemon water, but it wouldn't matter anyway because your stomach acids is going to neutralize any alkaline foods that you eat. So but anyway, like detox is just such a just such a common concept that the fact that it's complete rubbish is probably going to take some people by surprise. You can't detox yourself. You can drink less alcohol and drink more water to help your liver do the job it's been doing all the time. You must have heard, some people must have heard about this urine drinking phenomenon, because it's getting actually incredibly common, which is to me quite scary. Urine is not toxic, it is toxic. It's very, very toxic, but it's not dirty. I'm trying to say parav. I don't mean parav. It's sterile. When it comes out of your body, it is sterile. It does not have bacteria in it unless you have a bacterial infection of your bladder or urethra at the time. But it is urea. It is the chemical that your liver has been trying to get rid of, which is what is made if you eat too many amino acids. If you've got too much protein in your diet, your liver turns those amino acids into urea. Urea is toxic and needs to be removed. So why anybody would re-drink it, I don't quite understand, but this is what's happening. So we're going to talk about a little bit about the myths and the facts. But the first thing I do have to say, and I'm sorry if I get anybody's backs up on this, that we have to understand that this is not about, I'm going to have my opinion and other people are going to have their opinion, and the truth lies somewhere in the middle. That's not the case. And it's actually, and we're going to talk about that, it's a logical fallacy to believe that. In some, you know, it's like saying that, you know, fascism, the thought that Jews should all be killed, Yom HaShoah, it's very appropriate, is one opinion, and, you know, liberalism is another opinion, and the truth lies somewhere in the middle. No, Nazism is just wrong. It's just awful. It's just horrible. There's no like middle point that we're going to say is true here. So when we're dealing with scientific evidence, the scientists are very careful to hedge their answers in a lot of we thinks. And the reason why they do that is because then you can't in science say that anything is an unequivocal fact. It is only as factual as the evidence that you have supporting it. And as soon as that evidence changes, the science is going to have to change with it. We're going to have to understand how the theory that we originally came up with must have been wrong because the evidence does not support that theory anymore. So this is the anti-vaxxer group that was furious after the study they funded actually debunked the vaccine autism link. I'm going to go into that. This was this is exactly what happened. I think it was Autism Speaks, which has now changed their theories a lot. They started off incredibly anti-vax. They still are incredibly controversial. They call themselves Autism Speaks, and autists say that they don't speak for them. You know, they get very upset when they say that they're speaking on behalf of autistic people, when autistic people say, hold on a sec, we don't think that. But they have changed their views, partially because of studies that kept coming out to say that vaccines and autism were not linked. So let's look a little bit at the history of anti-vaccination theories, because it's happened, you know, for hundreds of years. Back in the polio epidemic, the smallpox, back in the 1850s, there were issues of anti-vaxxers. Many of them were affluent, well-educated, fond of progressive causes. They tended to this was back in the 1850s, tended to throw themselves into other maligned causes of the era, including anti-imperialism, women's rights, anti-vivisection, and vegetarianism. And I think that there's a bit of a link there, because when you see people who are very anti-science, they often are liberal and believe in women's rights and, you know, anti-racism and Black Lives Matter, and all of these things we're very much drawn towards and we want to be a part of, and we want to, you know, you guys are feminists, I'm a feminist too. Wait, you're saying something about science that isn't true? Am I going to agree with that or not? I'm not sure. This is different, by the way, to the climate change deniers, who tend to be more right-wing. So climate change deniers tend to be less women's rights, less Black Lives Matter, and the anti-vaccinators tend to be more. And it's just interesting how those two things have this is a lot of text, which is I'm not going to ask you to read, but this talks about the different sort of rubbish that came out in the 1850s, such as vaccination could introduce a bioplasm into the bloodstream, carrying it with it all the vices, passions, and diseases of the cow. So because they were vaccinating people with cowpox to prevent people from getting smallpox, people at the time thought that you would become a cow if you had cowpox. People thought that the diseases could jump, but still, it caused immunization rates to completely decline. And then we had massive smallpox epidemics, and this only ended when, and there was also real problems, patchy oversight of vaccine production. Batch of tetanus that left 9 children dead of lockjaw because it actually had tetanus toxin in it. So 1902, an act was passed in America to prevent this from happening, which was one of the early precepts of the FDA, the Federal Drugs Administration. But the fact is that smallpox went away, and polio has almost entirely went away. So let me talk a little bit about how vaccines work. For this, I'm going to hopefully shift into my teacher modes, because I'm also going to try and cover the mRNA vaccine of COVID, which does not work in exactly the same way. Of the 2 COVID vaccines, we've got the Pfizer and the Moderna, which is just starting to go around in the UK, which is also an mRNA vaccine. So the first principle of a vaccine, which I'm sure you're aware of because the WHO has been putting out videos which have been appearing on my Facebook every 5 minutes, maybe they've been appearing on yours as well, is we need to have an antigen. And antigens are usually known as foreign molecules, but in autoimmune diseases, they're just a molecule that the body thinks is foreign. It doesn't mean that they are necessarily foreign. So for example, with hay fever, your body thinks that pollen is foreign and it's attacking it, even though your body's like, shouldn't be doing that because it's really not a harmful protein. They're usually proteins, antigens, and they are on the surface of bacteria and viruses. Now, if I was going to draw a virus at similar to scale of the bacteria that I've just drawn, it would be less than that. So just for clarity, these are absolutely tiny, but if I drew a tiny little virus, it also has antigens on its surface. Now, once the body has been exposed to a bacteria or a virus, the white blood cells produce a subtype of white blood cell called a plasma cell, which has a massive nucleus, which produce antibodies, which are little, they actually do look like little Ys, that are complementary. They have like a jigsaw puzzle. They actively fit the antigen. And this does a few things. Number one, it could just surround the antigen so that antigen can no longer do what it was supposed to do. So for example, the bacteria, the tetanus toxin is neutralized just by literally being surrounded. The antigen is surrounded by these antibodies, and it can't bind to the membranes that it was going to bind to on the neurons because it's just been surrounded. In some cases, they may cause bacteria to clump together. And this means the bacteria can no longer divide. And in some cases, these antibodies will bind to the virus and basically tell other cells in the immune system that this virus is bad, please destroy it. Problem is that what do viruses do to make us ill? They infect our cells. So our cells then end up hosting the viral antigens on their surface. So this is one of our cells, but it's still got these viral proteins because the virus, when it enters, it sort of fuses its membrane with the membrane of the host cell. So you end up with the proteins on the surface. But that means when the antibodies bind, they may destroy the host cell. And this causes symptoms. Some of the symptoms when we're fighting an infection is not the virus itself, it's the antibodies causing the death of our cells. So for example, when you have the cold and flu, you're producing tons of mucus. A lot of that is because of your immune system's response. And the way we really know about how our immune system feels like when it's responding and we're not ill is with the AstraZeneca vaccine. The first dose of the AstraZeneca vaccine, which makes you, if you're under the age of 40, I know they're now not going to be opening up to 30s because of their blood clots, which I'll talk about if I get time. It makes you feel like, like you've been run over by a truck. And it's got nothing to do with the virus. You're not being given a virus. You're being given a teeny little bit of mRNA that gets your cells to make a bit of these antigens so that your body produces white blood cells against the antigens. But you feel like you're going to die. I mean, I was in bed for 3 days thinking, oh my gosh, if this is my immune system response, then how much of when I'm ill is actually just the thing itself? And how much is just my immune system making me feel rubbish because I'm fighting the thing? And it's quite hard to differentiate. Obviously, with COVID, the big issue is that is not the COVID itself. It's people's immune systems that are going crazy out of control, causing massive inflammation in the lungs, which then causes people to be unable to breathe. So steroids is a protein that reduces this. Steroids cuts back on the white blood cells so that it actually prevents the lungs from getting so inflamed or reduces the inflammation of the lungs. That's why that dexamethasone in COVID-19 has been so helpful, because it's stopping the body's own immune system from destroying the lungs. So it's almost like COVID-19's got that autoimmune aspect to it in a similar way to things like lupus and I mean, there's loads of autoimmune diseases like, MS, things like that. And which is also probably why long COVID happens, because it's not to do with the virus itself, it's to do with what's happened to the immune system as a result of the virus. Now, with a vaccine, what we do is we've got a choice. We can either inject a weak bacteria, so this is a bacteria that can't divide, or a dead bacteria. So if I give us the possible options, we've got a dead bacteria. You can't kill viruses because viruses aren't considered to be alive. So we call it an inactivated virus because it's not alive, so it can't be killed. I know everyone says, we've got to kill COVID. You can't kill COVID. It's not alive for you to be able to kill it in the first place. It's like saying, can you kill a computer virus? Can't kill it. It's a piece of code. You can just stop it from causing harm. Or you've got the choice where you could just put the antigen itself into the vaccine. But our immune systems aren't stupid. Being confronted by a dead or a weak or an inactivated virus or just an antigen is not necessarily going to cause these white blood cells to produce plasma cells. So we have to add something to the vaccine. And all of this is where we come into adjuvants. Oh, sorry for my terrible handwriting. Adjuvants are chemicals on purpose added to vaccines to force our immune systems to respond. Because if our immune systems were left to their own devices, they would take one look at this dead bacteria and think, yeah, you're not worth making antibodies against. And this is where a lot of the anti-vaccination concepts comes along, because you're like, wait, hold on a sec. Why are they putting this in the vaccine? Why are they putting that in the vaccine? And the answer is sometimes because it just keeps the vaccine sterile. So, when it's being kept in the fridge or something. Shoshana, why are you laughing? What's funny? No? Okay, I can't hear you, you're muted. And sometimes it's because they're just forcing your immune system to respond to something that they would just not otherwise respond to at all. So that it's necessary. But in the tiny amounts that they are given, they will probably cause your arm to hurt. And that's important. Again, pain is what forces your immune system to respond to that area. Redness on the vaccination site is when your capillaries are dilating to allow more white blood cells to get to the area and hopefully produce an immune response. So a lot of the side effects that vaccines produce are sort of necessary. Something I always try to tell mothers is if your baby is getting terrible side effects to a vaccine, that's probably a good sign that they've actually got a good immunity to it. So I was like, when I was lying on my deathbed after the first AstraZeneca vaccine, I was thinking, well, at least it's working. I'm hopefully producing lots of antibodies, which is what I want, because it's not just the antibodies. We test for antibodies. Antibodies is what tells us that the vaccine has worked. However, what we really want is memory cells. And these are both many different types of memory cells. These guys are the ones that stick around. And they will produce antibodies much more quickly when re-exposed to the same antigen. So if you then get exposed to the same virus, or you get exposed to the real virus, having been previously exposed just to an antigen of the virus, you will produce so much more quickly those antibodies that you'll never feel sick. You might still feel a little bit off, by the way. When our immune system is fighting against something, our temperature does tend to rise a little bit. Anyone who's tried to track their temperature for a month because of any other reason will notice it does go up and down a little bit. And it's sometimes because we're fighting something, but we just never get the symptoms of it. Right. Having said that, one single bacteria has hundreds of different types of antigens on it, all different shapes and sizes. They will therefore produce hundreds of different white blood cells, all producing different antibodies. If a baby puts their hand in their mouth after touching their high chair surface, to be fair, even if you've cleaned it with Dettol beforehand, they are being exposed to hundreds of thousands of different types of antigen. When they get their biggest dose of vaccines, they get 5 antigens, plus some adjuvants to force their body to respond to it. By the way, this concept of these multiple hundreds of different antigens is what has led to what's called the hygiene hypothesis, which has still not yet been disproven, waiting for some evidence to say that it's not true, where we're trying to work out why asthma and eczema is increasing so much in young children. And we think it's because all of these antigens that babies were supposed to be being exposed to in their first year, they're just not anymore because we're also clean and we're wiping down surfaces with Dettol, which is why we often see that the eldest child has more allergies than the younger children, because by the time you get to kid 4, you no longer care if you've boiled the dummy in its sterilizer when it dropped on the floor. You just like rush it under the tap, or in my case, wipe it on your. I actually did this thing where one of my children started to show an allergy to tomatoes. So I stopped cleaning my floor and I started putting raisins on it. And it worked. Their tomato allergy disappeared. This only works, by the way, if you do it before the age of 1. Which is also they're trialing a vaccine where they give babies all the antigens that they should have been exposed to in their first year, just to try to prevent these allergies that people are getting. Okay, I'm going to go back to my PowerPoint. No, I'm not. Sorry, I'm going to clear all of that, and I'm going to try now and explain how the 2 COVID vaccines are very slightly different. First of all, I can only see a few of your faces. So can the few of you that I can see tell me how you're doing so far? Like a thumbs up or a thumbs down? Okay, you're with me. Okay, so the 3 of you who I can see your faces are with me so far. Right. The COVID, Moderna, and the Pfizer vaccines do not give an antigen. The AstraZeneca does. They give a type of coronavirus that I think is in chimps, but it doesn't cause disease in humans. I think it's the one that's in chimps. And likewise, the Johnson & Johnson single dose one is also a straight antigen. It's a virus that, again, doesn't cause disease in another animal that has been weakened. So it doesn't cause disease in humans, but and it's been like edited slightly so that it creates an antibody response without causing the disease. But the Moderna and Pfizer vaccines don't do this. And this is where people got quite scared of the, I can't spell Pfizer, of these vaccines, because they are a new way of vaccinating. However, they are not a new technology. There has been a drug in multiple sclerosis that uses mRNA to cause the body to create a protein that is missing in MS, some subtypes of MS. I think it's been in the market now for about 8 years, if I'm not mistaken. And there are many, many more medications in the pipeline, because this mRNA situation is really going to like revolutionize drugs. By the way, my A-level just got RNA inhibition stuck on their spec 4 years ago. And as I say, anything that's coming up in science tends to get added to the biology A-level specification, because they expect that students who leave the A-level are going to go on to degrees where they're going to need to know this stuff, which is why my spec changes every 5 years. So we've got a cell and we've got a nucleus of a cell. Inside the nucleus of the cell, we've got DNA. Outside the nucleus of the cell, we have little structures called ribosomes, and these are going to do protein synthesis. But the DNA never leaves the cell. So how does the code for all the proteins in our body leave the nucleus? The DNA never leaves the nucleus. How does the code get to the ribosomes, which are going to be making the proteins? So what the DNA does is it makes copies, little templates, which do leave the cell, and this is called mRNA. This mRNA heads to the ribosome and causes a protein to be produced. So you get a little protein coming off the top of the ribosome. The protein can then head to the cell membrane, where it sticks onto the surface of the cell. Alternatively, this is if the DNA does it. That's a normal way of doing it. With the Moderna Pfizer vaccine, we introduce manually, artificially made mRNA via the vaccine, it enters the cell, never enters the nucleus, and the ribosomes that are there anyway make the protein out of it. So a lot of people got confused because by saying mRNA, people don't remember. It's been a long time since non-scientists did any of this science. And some of you, as again, mRNA is only on one of the specifications on the current GCSE. They don't even learn the word mRNA on the GCSE at the moment. On the AQA, EdXL, they don't learn the word mRNA. So this is not going to be on most people's knowledge basis. This mRNA never enters the nucleus, and therefore it can never have any effect on the DNA, because it just doesn't. The nature of mRNA is it never enters the nucleus. The only way is out, basically, of the nucleus, never in. But these ribosomes are doing the task for us. Instead of injecting antigen, like we do with many other vaccines, we force the ribosomes to make the antigen, and then we have the same thing happening. You get your antibodies made by your white blood cells, and then you get your memory cells, which will then produce antibodies more quickly the next time. Will this result in the destruction of maybe these cells, as the white blood cells might destroy them, thinking that they're infected viral cells? Yes, perhaps that will happen. And that could lead to some of the side effects that we feel. When the original infected cells, well, they're not infected, but they've got this mRNA in it, they've shown that antigen on the surface of their membrane, that could cause the body to actually destroy those cells. Just like a cell that was infected with an actual virus would be destroyed by T cells of the immune system. But it's not going to affect the DNA. And once that cell's gone, that's it. The other cool thing about mRNA, which is what makes it really good for a vaccine, is that it doesn't last very long inside a cell. Cells, anyway, only live for a certain amount of time depending on what cells they are. But the mRNA itself gets broken down by what's called RNA interference pretty quickly. So you've only got, I don't know, I can't remember what, it depends on the type of mRNA, depends on the protein, but I think they think it's only a couple of days before the mRNA is destroyed by the cell anyway. Might be as much as a couple of weeks. And then that's it. The mRNA is gone. You're not going to get any more proteins made. So it's a very short-term response, which in MS means that the drug needs to be given quite regularly, because they're still going to have to take more of it because their cells are going to stop producing that drug, which is also why they're now trying to interfere with the things that break down the mRNA. They're actually looking at what's called RNA silencing. They're trying to stop that from happening so the mRNA can still be there and therefore work as a longer term treatment for things like MS and other diseases where there's a problem with a protein being made. By the way, really exciting for us Jews, this could lead to a Tay-Sachs treatment, because Tay-Sachs is where there's a DNA mutation that's creating a malformed protein. That malformed protein then builds up in the neurons of the babies and unfortunately causes them to die, usually by the age of 3, sometimes they live till 5. If we can harness this method to create the correct protein, either through what's called CRISPR, which is where we actually edit the DNA itself, or in the meantime, this mRNA process, we could get the babies to produce the correct protein and therefore not have the wrong protein building up and causing all that. And there's some research being done into an mRNA-based drug for that at the moment. So that's quite exciting. Okay, so that's how both of those, and they're both very similar, slightly different code of mRNA. The key bit is the protein itself that they are both coding for is what's called the stick protein on the virus. So if we've got a virus, in order to get into a cell, it's got to attach to something on the membrane of that cell, and then that will cause the whole virus to get drawn in to the cell. And it's this protein that mRNA is coding for. This is the stick protein. And the reason why they chose that rather than any other protein on the virus's surface is because they hoped that this one is going to mutate less. Hence, all these new variants that are coming up, we're hoping that the current vaccines are still going to cover us, i.e. this protein would need to mutate quite a lot. Sorry, the virus would need to mutate quite a lot before the stick protein will change. Yes, and that's what we're currently seeing. And by the way, that's the case for all the vaccines, because all of them are using the stick protein antigen. Whether or not they're getting your mRNA to make it or putting the antigen in the vaccine itself, they're all for the stick protein, because they all realize that the only way we can treat coronaviruses is by targeting the stick protein. They've been looking for a cold vaccine for donkey's years. Who wouldn't like to not get a cold? But it doesn't work because it keeps mutating its stick protein. So there's like the flu vaccine that mutates at stick protein. It just doesn't really work. Okay, so now I'm going back to the PowerPoint. Annoying thing is I gotta move that a little bit. New share, PowerPoint. Right. I see a comment on the chat. I'm just seeing if it's a question. Yes, Shoshana, you have a question.
And now I have two. The first one was actually going back all the way to when you were speaking about how we keep everything sterile, and so kids don't catch the necessary stuff, and then that's or they think that there's a causal link between what we're doing, how we're sort of buffering our kids, and the incidence of hay fever and asthma, eczema, and all of that.
Yeah.
With COVID, for kids, for babies who are, I think they're calling them COVID babies, the ones who were born near the beginning of COVID, and they've literally not had interaction with other kids at all.
Yeah.
I mean, is there going to be some kind of an explosion of illness among that age group?
Yeah, I'm going to make a bet, and I'll put money on it, that when those kids start seeing their relatives and family members, they're going to have cold after snotty nose after flu, which is exactly what any of you who've ever put your children into childcare will have experienced. You start them in nursery and then they're off it more than they're on it, because they're catching everything from everybody in the nursery. But we're probably going to see that more. We're probably going to see that
but I suppose,
I don't think it's going to be, is it going to cause long-term effects? Hopefully not. But then I guess it's still the same, you know, like, have all these parents who've been at home for a year with their newborns, have they been even going to the park with their newborn? Have they been going to another person's house with their newborn? So really, they've only been exposed to the antigens within their own home. So yes, we could very well see an increase. We'll have to see. We're probably only going to know when that age group of kid gets to about 5 or 6 years old. We may very well see that. Which is better? It's not about better. They're using different methods. The Pfizer, because of the nature of the mRNA code, I'm guessing, and I think this is the case, is less likely to be affected by the new variants, because the way the part of the stick protein that the mRNA is coding for is just far less variable than the AstraZeneca, which is using a weakened, an inactivated chimp actual virus, which is therefore causing it's got lots of antigens on its surface. So some of them are going to mutate. Some of them are going to be different from the new variants. So Pfizer may very well end up being a slightly better vaccine. But we're not going to know for until we see how these new variants are being affected by the various different vaccines that people have been receiving. So over the next sort of 2 years, if there are more increases, they'll probably do tracking, like, did you get vaccinated? Which vaccine did you get? And then they'll start to be able to tell, which vaccine is more effective for which for the new variants. And then therefore they might start doing, more catch-up vaccines, right? Everybody got the Astra, we want to bring you in for a Pfizer vaccine now. Or everyone who got the Pfizer, we'd like to bring you in for a Moderna. Or, they might start doing things like that because they just want to couch their to sort of cover their bases. The other advantage of the Pfizer and the Moderna vaccines is that they are easier to edit if the stick protein changes. Because the way we make that mRNA artificially, it's quick. We can more quickly change those vaccines. And given that everything else in the vaccine is still going to be exactly the same, just maybe one base in that code, you won't need to go through the entire year testing process, because you're just changing out a base. You're not changing any other ingredients. You're just shifting the code so that the protein made is slightly differently shaped, so that it's more likely to match the stick protein. What you do have to make sure, though, and this is where the blood clotting thing happens, is that the antibodies that have been made, are we absolutely 100% sure that they do not bind to any protein in the human body? That is really important, because antibodies aren't fixed. It's not like a true fixed jigsaw puzzle piece. They vary. They've got a hinge, and that hinge means that the flaps of the two arms can move a little bit, which means that if my antibody is complementary to my stick protein, with a little bit of a shift, it might be complementary to a clotting factor, which causes suddenly that clotting factor is all being bundled together by this antibody, even only partially, even if it's not a perfect fit, but it's just a little bit of a fit. Suddenly this clotting factor is being it's called agglutination. They're all being glued together, and we're getting these rare clots, which could very well be seems to be only in younger people, again, because of the nature of the proteins that we have. So we have to really check that the antibodies that we make are completely not complementary to anything that could ever be in a human body. And given that me and you have very slightly differently shaped proteins, not always, most of our proteins are identical, completely identical, and not even that, they're identical to chimpanzees as well. But very occasionally we have very slight nuances in our proteins. We have to make sure that those are covered. And the way that drugs companies do this, and this is probably why the drugs are so expensive, is they run these antibodies, the antibodies made from the protein, across hundreds of thousands of compounds and proteins that exist in the human body. So you've got these massive machines called high throughput screening, where on the little these little plastic wells, you've got all the antibodies with like something to color change. And then you sort of, no, sorry, it's the other way around. On the little wells, you put all the proteins in the human body, every single little possible protein in the human body. And then you sort of inject into it the antibodies with a color changey thing. And if the color changes, it's because the antibody's bound. We can't use that antibody. It's complementary to, I don't know, this random protein on some people's kidneys, and therefore could cause a kidney problem. By the way, a friend of mine had this. Every time she got a certain virus, her immune system attacked her kidneys. It's a specific type of autoimmune disease because the antigen on the virus was very similar in shape to the random protein that happened to be on her kidneys. So I don't know. I hope that sort of helps you to like understand where this clotting thing is coming from. It could very well be a real thing, and this is why, how long did it take between the first clotting things being heard about and the withdrawal of the vaccine for under 30s? Was it 3 weeks? I think it was perhaps 3 weeks from France and Germany saying, hold on a sec, we need to look into this more. And England saying, you know what, we've looked into this a lot. Let's not give this to the under 30s because it might be that in the under 30s. Now that's pretty fast in terms of vaccine response for safety. That's pretty fast. So let's look at effectiveness now. Now we know that vaccines are effective. And I know that the anti-vax websites and the stuff that people put on Baby Center usually concludes graphs saying, yes, but people stopped dying of measles long before the measles vaccine came along. Well, yeah, in a rich country like America and the UK, they definitely stopped dying of it because we had nice hospitals where we could give them immunoglobulins and we can give them all sorts of other things. But, what are we going to do? Just say, well, yeah, boo sucks to everybody in the third world who doesn't have a nice, we don't call it the third world anymore, do we? The developing world that doesn't have a nice hospital that can treat, where there are still 18 million people dying of measles every year. And then what happens when they come to America and bring their measles with them? And what happens when they have measles running around their area, mutating, which is what's happened with mumps in the last 7 years. Mumps mutated because of the number of people who were not getting vaccinated. It was circulating, and therefore it mutated, and the MMR stopped working. So we got children who had the MMR getting mumps, and then they had to edit slightly the protein that was in the mumps, the MMR, to compensate for this. So as long as the virus is out there, it's mutating, and that's going to call into question whether our vaccines are going to work in the long term. So if you've had, I had the M and the MR when I was at school. I just got the MMR last year. I got my 2 doses of the MMR. I'd never had an MMR. I'd had an M, the measles, and I'd had an MR. Never had an MMR, went and got it, because even the M that I'd had is unlikely to properly cover me for the current subtypes of measles that are going around. This is the Cochrane reviews. And the Cochrane reviews are really, really good because they do what's called a meta-analysis. They don't just look at the studies, they look at the quality of the studies. Were these studies biased? Were they funded by a company that had a vested interest? Were the researchers on it? Did they have a vested interest? Was the statistics done on them done well? Did they double blind it sufficiently? And then they come out with these reviews that say, whether or not they were, whether or not the study is good quality evidence or low quality evidence. And they basically said that, 87 studies with 13 million children assessed the unwanted effects of the MMR vaccine. 2 studies with 1,194,000 children found no evidence of MMR vaccines being associated with an increased risk of autism. By the way, again, another anti-vaxxer comment is they've never tested it against people who are not vaccinated. Well, this is exactly what these studies did. They looked at 500,000 children who had not been given any vaccines, 500,000 children who had received some vaccines, did the ones who didn't get vaccine have more autism than, or have less autism than the ones who did? The answer was no, it was exactly the same. So the reason why autism's been increasing, and I could recommend a brilliant book called Neurotribes. And by the way, if you ever work with autistic people, which everybody does, we all work with autistic people unless you work by yourself and you never come into contact with human beings, because there are so many people are on the spectrum. This book will really help you understand them better, even the really, really mild ones. And if you read it really well, you start to see the little traits of autism in yourself. You're like, oh, that's a bit. And I'm betting in 50 years we will not have this single word autism for what we now consider to be these traits. They're going to be multiple different words, and we'll be like, I've got subtype 352, which means I'm slightly more gullible than the next person. And I
think now we don't have a catch-all term. We call it an ASD. We call it a spectrum rather than
but it's a spectrum, but that's just disguising the fact that we're probably dealing with 300 quite unrelated disorders. I don't even want to call them disorders. I don't consider them to be disorderly. I think if you've got enough of them, it makes it very difficult to interact in our today's society. And unfortunately, in some children, they are no longer able to verbally communicate, and their world is an incredibly scary place. But we all need clusters of those genes. We all need bits of those traits if we want to be creative, if we want to be an engineer, if we want to be good at maths, if we want to be musical, if we want to have all these different clusters of the parts of us that make us human. The problem is you get too many of them, it starts to become very difficult to function in the society. But is that the problem of the disease? I don't want to call it disease. I don't even want to call it syndrome. Neuroatypicalness, or is that a problem of society that doesn't compensate for differences in people? And that's why I think that reading that book's really helpful, because then you start to see all those difficult people that you thought were just difficult. You're like, oh, they're just autistic, and suddenly all of your negative feelings towards them goes away, and you start to try and deal with them at their level. Francesca's disagreeing. They're still difficult. Okay. Okay. Right, I'm going to give you the access to this PowerPoint, anyone who wants it afterwards, because there's some really, really interesting things over here. This is just an image, a picture, just looking at the number of deaths, 41 deaths in Ukraine. This is from 2019, I think, 2018 to 2020, 2019 to 2020. And we've got Madagascar, where there is ridiculous numbers of cases, and I can't unfortunately see them because it's blocked by my Zoom thing, but I know it said that there are a huge number of cases and deaths in Madagascar. I don't know why Madagascar particularly. I do know the Ukraine has a huge number of cases because they have a very, very strong anti-vax population. Romania is very similar, by the way. But this app over here is the one I want to show you. Hopefully it works. It may take a couple of seconds because I'm using Zoom and the internet and blah, blah, blah. But this is a really, really excellent website where you can just track the coverage of vaccinations. How vaccinated is our area? And this is where, you know, where people say, well, everybody else will be vaccinated, so my kid doesn't need to get it because he'll be protected by everyone else. That is no longer the case in London. Let me show you. Kensington and Chelsea has a 77.2 vaccination rate for the MMR first dose. Just so you know, herd immunity is around 90%. So measles will stop being transmitted from person to person to person if 90% of the population is vaccinated. We are 17% lower than that in Kensington and Chelsea. And I'm going to show you Barnet because that's where you are.
Ilana, we can't see the screen.
Oh.
We're still on the measles outbreaks.
Why is it not coming up with it?
Yeah, we can see it now.
Where's Barnet's not coming up with it? Saying 83.6%. So just below 7% less than herd immunity. So we no longer have herd immunity in most of London. So the last measles outbreak 2 years ago was comparatively not as bad as it could have been, given that we don't have herd immunity anymore. Yes, I will check Kingston and Surbiton for you, but I'm going to give you the PowerPoint so that you can look at, you can find this website yourself. Let me just pick it. Actually, if I do the whole area, region, I can just pick London and then you get all of the list on the sides. And this data is from 2019 to 2020. Oh, except I've still got Kensington and Chelsea picked. Where are we? Lambeth, Kingston and Merton. Kingston upon Thames, 87%. So still 3% below 3% below what's it called, herd. You can also change this and check the pertussis vaccine, which is the whooping cough vaccine. Whooping cough does have a 4-year cycle. Every 4 years, whooping cough gets worse. No matter how vaccinated everybody is, whooping cough tends to go up in 4-year bouts. The last whooping cough bout was, I think, 2 years ago. It might have been last year. So we should be a couple years before the next bout. And in the meantime, we really don't want to. There's a way. Here we go. MMR at 24 months. So that is the DTaP. No, it's the DTaP at 4 months. I want to look at. That's the first time that anyone is given a DTaP. They don't have data for that, so I'll have to look at the DTaP IPV Hib. Hib is a type of meningitis. And again, how do I unselect the fact that I've selected Kingston upon Thames? Is there? Can anyone see if there's a reset button anywhere? No, can't see it. Kingston's at 91%, pretty good. Barnet's 88.6%, so we're at below herds. Brent's 88.6, Harrow 87.3, sorry. And interestingly, this is the one I really want to look at. Tower Hamlets for the pertussis vaccine is quite high, 92.5. Hackney, why am I picking these guys? 73.6%.
Is this the cultural diversity there?
Who lives in Hackney? Cultural diversity. We've got a really big anti-vax problem in the Haredi community. And sort of part of our job as modern Orthodox people is to try and explain the science to people who didn't have a science education, just didn't have one. I'm not talking about the kids who went to Lubavitch and Yesodei HaTorah who get science education. I'm talking about the ones who don't. And so we do have a little bit of a responsibility to coming from the same religion. Yes, we're coming from a very different background, but from a non-judgmental, understanding place, and say, you guys have, this is actually what's happening. This is some of the lies that you might have been told. This is how to understand those lies. Especially for people who leave the derech and do end up joining our communities, to really help them, understand perhaps what they may have absorbed whilst they were in those communities. In Hasmonean, the only kids that ever get measles are the ones that come from Stamford Hill. And I have been very clear to the school that if, it's so funny because it was 2-3 years ago, I actually said to the school that if we get any more measles cases in the school, I will wear a mask all day, every day. Guess what I'm doing this year? Wearing a mask all day, every day. We never saw that coming. Okay, so let's talk about some of these reasons. Why do people get, all of this? Because again, the reason why I'm looking at this is if we can acknowledge that impact in ourselves, and I realize that, I haven't got a huge amount of time to go through all of these, but if we can acknowledge where this is coming from, then when we are confronted with some of these ideas, hopefully we'll be able to overcome them a little bit. So we think, I know why they're saying that. That's what they're trying to invoke in me or in other readers. So therefore, I'm sort of not immunized, but at least sort of aware of the propaganda that is being used against me to try and come up, to try and force an opinion on me. And the problem is that, as you'll see with many campaigns for vaccination campaigns are always about trying to gently and calmly explain to people the science. And that's never going to work when you've got a lot of emotions on the other side. And you'll see that all of the propaganda against vaccines is trying to engage those emotions, to really get us scared, to really get us worried, angry, fear of the government having control over us. Against that, cool, calm, collected science has got no hope. And what you're going to find is you're going to try and express cool, calm, collected science to people who are very emotional, and you're going to get called patronizing, and you're going to get called a shill. You know that word? You're a paid representative for the pharmaceutical companies, who I would love to be, because then I'd maybe be able to get to the end of the month without going into the reds. But I'm not, unfortunately. So one of them is fear of the man, and how trust in the pharmaceutical companies, trust in the government, trust in the medical professions basically leads to people not wanting to get vaccinated because they've stopped trusting. And a lot of that, have to be said, has been fueled by America, where medicine has been monetized. And as you'll be aware of the politics with Obamacare and things like that, most people can't afford good insurance, and the insurance companies are very good at ripping people off. Even when you're insured, you still have to pay some way towards the cost of your treatment. And the key part is you see the bill. Here we don't see the bill. When I go to a farm, unless you're going private care, when I go get my 3 monthly blood test, I've got no idea how much that costs the NHS. Around £190, just so you know. The same blood test in America on insurance will cost around $600. That's not equivalent dollar to pound, because the insurance company would have inflated it. But I don't see the bill here, so I don't think it's expensive. So I don't think that someone's making money out of me being ill. Whereas in America, people do think that. Plus, they've got adverts on TV for medications, which is starting to happen a little bit here. Like adverts for actual prescription medications on television, which again, make people think all they want to do is make money out of us. And again, I mentioned before, lack of science understanding. So you may have seen some of these memes. These are just memes that have come up. You know, the first one, Black Plague disappeared without a vaccine, just saying, yeah, after killing a third of the population of Europe. So, you know, not so great. Why would my unvaccinated kids be a threat to your vaccinated kids if your social vaccines work? This comes up all the time. The answer I hope I've already covered is that if your unvaccinated kids spread the virus, it's going to mutate, and my vaccinated kid will no longer be covered because you'll have mutated the virus for me, which is what happened with mumps. And then you've got, you know, these fear mongering. This is very fear mongering. This is to create a negative emotion, to create a fear, scared emotion. And come to how that's going to make such a big, massive difference. Anecdotes, stories. I've got a friend whose son got the measles vaccine, and 2 months later, he started expressing symptoms of autism. First of all, this has been thoroughly disproved. Through eye gaze technology, we can work out which kids are autistic from birth. The parent will never have seen that because we can't track the changes that the computer can. But the computer can see whether or not the baby is looking at a face or it's not looking at his face as much. And then they did, it was statistically significant. They're able to work out who ended up showing more symptoms at 18 months and then going on to get an autism diagnoses later on. But this was seen at birth. So there is no, I mean, hepatitis B is given in Israel at birth, but nothing else. And plenty of countries don't give the hepatitis B vaccine. So yeah, the concept of what peer-reviewed research is, why scientists say we think, because they never know for sure. And it all sort of undermines science. And stories, again, they create an emotional response in us. They're also more easy to remember because of those emotional responses. By the way, this is when I teach in school. I always try to make the kids either laugh or feel disgusted. Because if they have an emotional response to what I'm saying, they're much better at remembering it. It just works. So emotional responses, you're more likely to remember it. So your friend's son you're going to remember that more than the peer-reviewed study that you read or the peer-reviewed study that your doctor referred to. This is the compromise effect. The compromise effect is what I mentioned before. If me and you have opposite opinions, the truth lies somewhere in the middle. That's not true. And therefore, we've got to sometimes realize that actually some people can be 100% wrong. But I don't need to accept their point of view if their point of view is coming from a complete lack of information. And then, of course, we've got the Dunning-Kruger effect, which is, I think, has got some interesting terminology that has been related to it since the last American elections. But basically, this is that the less people know, the more they think they know. And the more you know, the more you realize that you don't actually know very much at all until you become like a PhD, where you're suddenly like, okay, you know what? I think I have enough information now to be pretty sure on this. But everyone pretty much, you know, and that's very, very specific PhDs. They're, you know, so like someone's done a PhD in, you know, electroencephalo, and what's the thing my ex did? Electroencephalo something resistors across the stomach. I can't remember. He can be pretty sure about his research. He can't really be sure about anything else in what's it called, medical physics, because he didn't do his PhD on that. Science is very, very narrow and specific. And people in scientific disciplines often don't talk to each other very much, like in different disciplines. Okay. Risk perception. This is a really big issue when it comes to vaccines. And this comes to those negative emotions that I came before. There's loads of this stuff. There's brilliant books on risk perception. You can read Thinking Fast, Thinking Slow, anything by Daniel Kahneman, anything by Dan Ariely. These are great books. They're also just good reads. You know, if you want to, I'm not good at reading nonfiction. These are excellent nonfiction books. Explain how we view risk, how we make decisions based on our emotions. Once you know about it, it can sometimes help you try and counteract it. But effectively, we're really bad at perceiving risk. And this is the really key thing, if a action has a possible negative outcome, we're basically not going to do that action, even if the inaction has a even much more likely negative outcome. So let me explain this. If I don't vaccinate my child against measles, there's a possibility that they will get a side effect, a very bad effect from getting the measles. First of all, there's a possibility they may get measles, and then there's an even smaller possibility that they'll get very ill as a result of that measles. So that's inaction. Alternatively, if I act and I do something, I give my child a vaccine, there are known side effects to those vaccines. Nothing is 100% safe. It is not possible for something that works to be 100% safe, which is why, by the way, we know that anything where they claim there's no side effects is because there's nothing in it, right? If any complementary or alternative health therapy says there's no side effects, it's because there's no evidence that it does anything. So just be aware of that when you're being told, when you see something coming up on the screen, no side effects. Oh, well, that's because it's not going to do anything. Beyond placebo, which I'm not denying is a very strong effect, the placebo effect, the one where we think that things will work and therefore they do. By the way, this works even if you're told about it. So if I tell you I'm giving you a placebo, it still is more likely to work than nothing. This also works, by the way, you can tap into this placebo effect. If you spend more money on the paracetamol, it works better. So you go to the Boots and you see the generic Boots for 16p paracetamol tablets, and then you see the Anadin Extra, whatever, and you look at the side and they've got exactly the same ingredients in, but one costs £3.80 and the other one costs 16p. If you buy the £3.80 one, it will actually work better. And I promise you, even the contents of the pills, even the way that they dissolve in your stomach is exactly the same. You just spent more money on it, it will work better on you. So it's not a reason to not get the 16p one, you know, because even me telling you this, it will still work. It's amazing. The fact that I've told you this will happen, it will still happen. But yeah, as I said, we're more likely to not act because of a possible risk than we are to act because of a possible risk. So that's all about risk perception. Peer pressure and social media. This is the study that I'm sure you're all aware of, where we see that in the last 2 months, that 65% of all of the anti-COVID-19 vaccine information was spread by 12 people, none of whom is two of whom are chiropractors, osteopath scientists, and the rest of them are not scientists at all. Now, I'm not going to diss osteopathy. I think it's a very, very, in the UK, 100%, they do a ton of medicine to become an osteopath. I'm not going to speak for osteopathic MDs in America. I don't know what their training is. But I do know that the two of the anti-vaxxers that have been spreading all of this information, and these two links will go to that, so you can go to that in your own time. We've got conspiracy theories. Has anyone seen this image? This is what's called the anti-Semitic point of no return. So we start at the bottom, all of the things grounded in reality. Then we go into the skepticism, UFOs, did Epstein really kill himself? Was Princess Diana killed by the royal family? That stuff that, you know. Then we move into stuff where you've left reality completely. Elvis is still alive. Crop circles are made by aliens. There's the Loch Ness Monster. Then you move into complete science denial. So there you've got your anti-vaxxers. Global warming is a hoax. Chemtrails. My husband says chemtrails just to get my back up, by the way. So, oh, look, chemtrails. And I'm like, they're contrails. And then here we get to this point where anyone who really, the problem is, look how close anti-vaccination is to when things start getting anti-Semitic. And this is what we've seen with COVID-19. We've seen a lot of the people saying that they're putting, you know, microchips in the vaccine. It's all a 5G conspiracy. The vaccine was created, comes back to, someone mentions Rothschild, somebody mentions the Jews. And on the Facebook pages before they were shut down, a lot of them had these anti-Semitic overtones within the anti-vaccination stance. Okay, magical thinking. This is where we experience an irrational fear of performing an act because we're assuming that there's a correlation between the act and the calamity. So, for example, every time I wear this top, it rains. So I'm going to stop wearing this top because I don't want it to rain. It's completely irrational. We are trained as Jews, depending on how religious you are, to magically think. We are told to believe in things that are irrational. I'm a religious Jew. I'm sitting here telling you I'm a religious Jew. I am told to believe in things that have no rational basis. There is no way I can empirically prove that praying for my friends will help them. It won't. There have been studies that have tried to show it. They've been disparate. They weren't very good studies. It was whatever. God doesn't make it so easy for us to believe, right? That's otherwise there's not much of a point in you know, it's not called faith if it's like so evident, like, because otherwise everybody would, why would anybody not believe if it was so easy to believe? So the problem we've got is, this is why I come back to Stamford Hill, the Hackney, you know, Tower Hamlets area, is when you've got a group of people who have not got a scientific background and are told to believe things with no evidence behind them, they're going to be much more likely to believe somebody telling them something that has no evidence behind it, because they're not used to asking for evidence. They've not been, you know, their whole belief system, their whole belief structure is based on a lack of evidence. That, you know, that they keep an entire lifestyle with no evidence to say why kosher doesn't help make us healthier. No matter how which way you fry it, nowadays kosher is not healthier. It isn't, and yet people are keeping kosher. There's no evidence for it doing us any good. The evidence is all, there's no, we have to just trust that this is what God wants from us. So therefore, they're going to be much more likely to believe in other people telling them things that have no evidence behind, especially those people who are their own rabbis, because they're already used to listening to those rabbis for everything. So if their own rabbi tells them something, they would never question their rabbi. Bad journalism. I know I'm like way over time. 4 minutes, only 4 minutes over time. Bad journalism. This is a graph of, is the science content compelling enough to read? So Nature is pretty tough to get through. Anyone try to read Nature magazine, a Nature journal? It's pretty tough science. New Scientist is a little bit better because they do try and at least to make it a bit more, you know, but still, if it helps if you have a scientific background to understand New Scientist, all the way through the what I call the Daily Fail, which is, you know, I mean, everybody can understand it, but it bears no relation to reality. But I show you some of the studies that, I mean, I can quote some of them actually. Let me just, I have to get out of the screen sharing to get to my quotes. I don't actually have to, but because I just set up my PowerPoint a bit wrongly. Here, I'm gonna just read it to you. These are true what's it called? You're gonna hate or love this one depending on how you're gonna do it. This is the Telegraph. Telegraph we know is a broadsheet. This isn't, to the Telegraph we would hope is not a tabloid. It's not the Daily Fail. A study. The Telegraph's headline was, men are more likely to rape women who are drunk and provocatively dressed. Now, everyone knows that's going to tap into all of the victim blaming that we know is like a terrible, terrible thing. The study it referred to had no significant difference on what the women were dressed, and actually showed the men were less likely to continue an interaction with a drunk woman. So the Telegraph managed to get from less likely to interact with a drunk woman and no effect on what the woman's wearing, to more likely to rape women who are dressed provocatively and drunk. That's opposite world. And that's because the journalists that share the science, that write that down, often don't have scientific backgrounds. So they just literally just get it wrong. Okay. Where am I? So, no, I'm sharing the wrong thing, sorry. And it's managed to delete where we were up to on the PowerPoint. That's always fun. Oh, that was the last slide. Excellent, that's why. Okay, so within hopefully some of these, we've seen sort of the things that can happen to make you, and it can be really compelling. And I'm going to be very, very upfront and honest here. About 10, 15 years ago, I started to think maybe they had something to it. You know, maybe they're a bit right, the anti-vaxxers. Maybe there's something to it, especially, here's a story, when my friend, who I convinced to get the hepatitis B vaccine to her newborn, her son ended up with autism, right? Those kinds of things really hit you hard. You know, I'd pushed her to get the hepatitis B vaccine for her newborn. She didn't know why she should. I said, why not? It's a free vaccine and he might have to get it when he's older if he wants to like work in a hospital or something. Their kid's never going to be able to work in a hospital. He's one of the less verbal, less able to interact with the society. And yeah, I felt guilty. I felt, oh gosh, could I have convinced my friend to do something that was ultimately bad for her son? Or could it have been the fact that she was taking antidepressants during her pregnancy, which has also been linked to an increase in risk in autism? Could it be the fact that she took paracetamol during pregnancy, which has also been linked to an increase in autism? Sorry, I know you're looking skeptical, Francesca, but they have. The studies were not terrible. They weren't amazing, but they weren't terrible. Or could it be the fact that she's got slightly autistic traits and so has her husband, and it's quite often genetic? Like there's a lot of genetic constants in it. Or could it have been all of the above? And are we going to ever know? because the fact, I'm not going to tell you and sit here and tell you that the environment doesn't have an effect on who we are as people. Of course it does. We're finding out more and more all the time that the environment does impact who we are as people. Vaccines, however, don't cause autism. And I got the AstraZeneca vaccine, and I'm getting my next one in 3 weeks' time. So I'm going to stop there and give you some time for questions, which I'm hoping. Is that all right, Shoshana? Because I've got more I can say if you want me to. I just think you told me an hour. You told me an hour, right?
Yeah, no, it's brilliant. It's wonderful. And I did ideally want time for questions if anyone wants to either use the chat function or just unmute yourselves to ask. And I wanted to ask a question, but I don't know if this is the right forum because I could probably personally ask you about this. But if it makes people comfortable to have someone else ask a question first, my son Ezra was born in Israel, and in Israel they do vaccinate against chickenpox, and he had one vaccination.
Yeah.
Is it, do I need to
Can't get it here, don't
privately get him another vaccination because he might get shingles when he's older?
First of all, the shingles vaccine is out there now, so we don't have to worry so much about shingles. As long as we get your shingles vaccine when you're older, then it's less worrying. Second of all, to get the private varicella vaccine is incredibly difficult. It's £120 per dose, which is not within everybody's remit. I've got 4 kids. I'm sorry, and I love vaccines, but £120. My eldest got the varicella vaccine. My other 3 did not, because I left Israel before my second was old. They get it a year, and we left when he was just under. I'm not paying £360 twice for my kids to get the chickenpox vaccine. Having said that, my second child got the chickenpox, and he got pneumonia as a rare but common, rare but common is opposites, but it's not that rare complication of chickenpox in the under ones. And he was really, really ill. And, you know, like it was just a horrific time. It happened, by the way, of course, these things always happen over Pesach, because, you know, that's Sod's law. So yeah, so look, chickenpox is much more worrying than we'd like to think. It's nothing compared to measles. Some children will get side effects and complications as a result of chickenpox. If you've got the money and you can go and find that vaccine privately, then, you know, you're very welcome to. I did look into it, and I found that it was going to be prohibitively expensive for me to do so. They have now added the, I think the varicella vaccine is much more available in America than it used to be. Here it's still not being, and the reason why is that every country decides basically with chickenpox what they're going to do. Chickenpox is most dangerous in adults. Yes, there are complications in children, but it's most dangerous in adults. But the vaccine is not 100% effective. It's not even 95% effective. It's around 75%. So you're never going to get to herd immunity with the varicella vaccine. But what you are going to do is you're going to prevent people being exposed to it. The less you're exposed to the chickenpox, the more likely you are to get shingles. And what the NHS did was thought, we'd prefer to have people more exposed to chickenpox than for our elderly to get shingles, because it really hits them terribly. But that all, of course, ended when the shingles vaccine was introduced. So now there's a shingles vaccine. We don't really have to worry about being exposed. Like I used to say to my parents, hey, my kids have got chickenpox, come babysit, you need to be exposed. Because, you know, the more they get exposed, the less likely they have to get shingles. My dad got shingles, and he was really, really ill, and he still has peripheral neuropathy as a result of his shingles. He's got whole areas of his back and neck that are itchy all the time as a result of nerve damage due to the shingles. But yeah, so like we have a shingles vaccine now. So, you know, it's like the TB vaccine. TB vaccine's only 75% effective. They stopped offering it to children. It's now optional for a year-olds. And I did want to get the vaccine. I did want to get it. When your baby is a year old and you have 3 other children under the age of 5, you know, it's difficult to make appointments. That's, by the way, some of the reason for the Hackney rates being low. It's nothing to do with because they don't want to vaccinate. It's because they've got a lot of kids, and it's difficult to remember which ones have had which vaccines and which ones needs an appointment for this and which one needs an appointment for that. It's nothing personal. In fact, the Barnett stopped sending out letters when your children need vaccinated. They don't send out anymore. So I didn't know. I was like, I remember calling up my GP and thinking, I'm thinking my kids are probably due a vaccine now, aren't they? Just before, you know, when my youngest was turning 3, 4, the preschool vaccine, they don't send a letter anymore. So this doesn't help. You know, all these things don't help. Yeah, I never got around to the TB vaccine with my youngest. I did with my other 3. Yeah, didn't get around to with the youngest. We're not in the low socioeconomic bracket that is more likely to be exposed to TB. Could they still catch it on the London Underground? Yes. It's a little bit less, it's much less infectious than you think it is, TB. You have to be around someone for quite a bit, and they're coughing up quite a lot for you to catch it. which is nothing compared to measles, where you spend 20 minutes in a room with somebody, that's it. You've got enough of a viral dose. So I think we forget COVID-19 is far less infectious than the measles. COVID-19, if the windows are open and I'm 2 meters apart and I'm wearing a mask, I've reduced my infection rate by like 30 to 60%, depending on how big the room is, the viral load that all of that sort of stuff. Measles, 9 soldiers were in a waiting room for 20 minutes. None of them were vaccinated. All 9 of them got measles. All 8 of the others got measles from the one person that was in the room. We don't get that kind of infection rate with COVID-19, although we do have a much higher death rate with COVID-19. Measles kills less than COVID-19. I don't know what your name is, but you have put your hands up.
Hi, I'm Sharona. Nice
Hi.
to meet you. Thank you so much. Your presentation is excellent. And as I said, I wish you had been my teacher. You're fantastic. I just wanted to ask you, based on what you're saying, it's interesting that you seem to be quite sort of chilled when it comes to vaccinations for TB or chickenpox, even though you said your own child became quite ill with chickenpox.
He didn't have the option. He was too young to get the vaccine. But it's still only a 75% effective.
Yeah, and nevertheless, you're quite pro the COVID one. Is that more than 75% effective?
To do with that, no, it's not more than 75% effective. It's got a higher death rate. Chickenpox just doesn't kill anywhere near as much as COVID.
No, but you had first-hand experience with
of
pneumonia.
Yeah, my kid had to have antibiotics for 3 days, and it was hell. But my kid didn't.
Yeah. But people can die of pneumonia.
But it's far less likely than COVID. So even though we've got a lower, and the fact is with COVID, with a 70% effective vaccine, we're never going to get herd immunity from COVID. We can reduce the spread. We can 100% reduce the spread. That's what we're all doing. We want to get the spread down, along with other measures like making sure that people who come into the country are quarantines, to stop this from mutating into new variants all the time. But until we get, and I think the Johnson & Johnson is coming up as a 90% effective now. A single dose 90% effective. So it could be that as that vaccine gets more, that then we will be like, okay, we now have a vaccine that could actually create herd immunity. Everybody go and get it, please.
So in that case, you mentioned that you had AstraZeneca.
Yeah.
And the fact that you're so knowledgeable about all of this, why wouldn't you try and go for like the Johnson one or the Pfizer ones, as you said, that they're, in a way more effective?
I'm going to get my second Astra because I think that when you've had one, you should get the second because you're producing antibodies to the same structure of the protein. But if in the future they say, first of all, I'm not going to take a vaccine away from anybody who should be getting vaccinated. We have not vaccinated enough of the population yet for me to be starting to say, I don't want an Astra, I want a Pfizer, right? I'm not going to start affecting the rollout by doing that. If it becomes available later on where we can buy or, get one of these vaccines privately, it might be that I say, I'd just like to get all of them because I have an underlying condition. I'm very nervous and I'd like to increase my coverage. When it comes to my children, I'm for sure going to be making sure that they're vaccinated. This, by the way, comes with the human papillomavirus, the HPV vaccine. Have you heard of that one?
Yeah.
That's this year was the first year that was offered to boys, year 8 and 9 boys. So as Orthodox Jews who circumcise our sons, I'm assuming we all are, but obviously those of you who aren't are going to have different, what's it called, risk versus benefit analysis. HPV, the vaccine has 19 different subtypes of HPV in it. By the way, they didn't put the subtype in for verrucas and warts. I think they missed a trick there. So I think if they put that subtype in and said, if you take this vaccine, you can't get any verrucas or warts, you would have got much higher uptake of it. Because anyone who's had kids with multiple verrucas would know if I could prevent that from happening. And my kid's got a wart on his finger and he keeps spreading it to under his eye. He's had to have 2 warts removed from under his eye. You know what liquid nitrogen is like in this area? It's agonizing. Anyway, HPV is a virus that causes cancer. It mostly causes cervical cancer, but it also causes anal cancer, throat cancer, and a few other types of cancer that are just very, very rare. But those cancers can also be found in boys who don't have cervixes, clearly, so can't get cervical cancer. Boys can spread that virus to girls who can then get cervical cancer. So by vaccinating our boys, we protect them against very, very rare cancers. What we're doing more is we're protecting them from transmitting the virus to girls who can get cervical cancer.
What did you say this is being offered in Hasmo?
Yeah, my son got the HPV vaccine.
Okay, because I've got a son in house mode, but I haven't had any notification about that.
What year?
Year 8.
He'll get it. The year 8 vaccines will be the end of the year, so he should get it in May. Remember, year 9's only got it because they were supposed to get it in year 8 because they never got vaccines in year 8 because of COVID.
Oh, I see.
So then the year 9's had to do a catch-up clinic for all the vaccines they were supposed to get. And then the year 8s will be offered probably around June, I'm guessing, based on.
Oh, wow. Well, it's good to know about that.
Imagine the argument on the WhatsApp group, right? People saying, oh, the vaccine. Yes, it does. And not only that, but circumcised boys are much less likely to spread HPV. Much less likely to. Circumcised, because when the foreskin's gone, the virus has not got enough places to like sort of sit. Which means that, you know, you've really got to think about it. There is a risk to a vaccine. There is always a risk to a vaccine. It's very low risk. I think with the HPV vaccine, it is 1 in 14 million that get serious side effects that need to be hospitalized. Nobody's died from it, but it's still 1 in 14 million. And you're only preventing against very rare cancers in your son. What you are preventing from is them possibly passing on a virus, possibly because they're circumcised, and so are they going to pass it on? And anyway, do we want our kids to be having sex? Clearly not. So we've got
what kind of side effects are we talking about from the vaccine?
1 in 14 million, we're talking about encephalitis, the brain swelling. The more likely the ones is you feel slightly ill for the next 2 days. I don't think actually this year we had very few side effects from the bunch of boys that got vaccinated. I think 2 years ago, I don't know why it was, but like I think there was probably peer pressure. Like 30 boys were off sick the next day, and we were like messaging NHS to like find out if we'd been given a bad batch, and they were like, no, it's just copycat. One boy started moaning. It's the what's called the nocebo effect, which is, by the way, the opposite of the placebo effect. Nocebo is if you expect bad reactions, they are much more likely to happen. So what you all need to do is when you go to get your Pfizer vaccine or your AstraZeneca vaccine, you're saying side effects aren't real. Nobody's going to get side effects. Then you're less likely to get the side effects. You go in there thinking, oh my gosh, I'm going to be ill tomorrow. I've got to take a day off work. You're much more likely to have to take that day off work. So we think there was a bit of copycat going on with that year 8 group. But yeah, there's a thing. And also with the religious girls, why would I vaccinate a 12-year-old girl? I don't want my daughter having sex until she's in, 18 to 20, 24 years old when she gets married. Okay, so obviously that's not always the case, much as though we would want our children to engage in healthy sexual relationships. And secondly, they don't just catch it from sex. It can be caught in other ways as well. But the vaccine has been so good, they're now offering it to divorced women who are re-entering the dating market because they might not have been exposed to HPV in their marriage. And therefore, let's just give them the vaccine now, because if they're now engaging in, they're now going to have sexual relationships with more than one partner, might as well protect them. Why not? And they no longer, by the way, our smear tests are all different. And if you've gone for a smear recently, they don't test us for abnormal cells anymore. They test us for HPV infection. Because if we've got HPV infection, then they'll test us for abnormal cells. They don't bother looking for those abnormal cells anymore because it's just much less likely to come up with telling us whether we've actually got the abnormal cells. You get that horrible, callback, which would freak everybody out and make you think, oh God, maybe I've got cancer, and then they're like, no, it's just a bit of this is just normal for those types of cells, and that callback sometimes would be like a few months. You'd have to wait for them anyway. They don't anymore. And in Australia, they're thinking about stopping the cervical smears completely because their vaccination rates has caused there to be a massive drop in cervical cancer. So I can understand the arguments for and against. I vaccinated my son, and once my elder ones get catch-up, my eldest, because it wasn't offered for him, I will put him on a catch-up. I don't think they're going to do catch-ups for a while, though, because it's not a cheap vaccine. The NHS have to pay for it, right? So they're going to do everybody as they come into the age, and then they'll then start offering it as catch-ups. Any other questions?
Yeah, it seems we're good. Seems you covered all the bases. I personally found that incredibly interesting, and I just loved the teacher skills as well. Like, you're obviously very au fait with Zoom, like a lot more so than me, who can't do the YouTube live, obviously, and has to call my husband to do it for me. But that's yeah. Thank you very much. I did say that I'd give a brief halachic overview as well. Now, I just want to preface that by saying that this is not my area, obviously, and I think that's really key. When something is not our particular area of interest or expertise, it's always important to go to people who do have the knowledge, who do have the expertise, and that there are times when we do need to turn to the science and not necessarily to I have to be careful how I put this, but we're lucky that in the modern Orthodox community, we have rabbis who are leading us in a very sensitive way and acknowledging that, for want of a better analogy, if I have a gynecological problem, I'm not going to see an ophthalmologist. So there's a point at which our rabbinic leadership also needs to say, well, at this point, we need to look at the scientific research. We need to look at medics and scientists and recognize that they have the knowledge that can feed into our decision making. So again, within the modern Orthodox community, it's certainly within the UK, there hasn't really been an argument. We're being encouraged to take up vaccines, not just COVID vaccines, but across the board. And yet, Ilana, you mentioned that we had some measles outbreaks a couple of years ago. Now, actually, I was living in Israel at that time. We've only been here. We actually moved here a couple of days before the first COVID lockdown. So that was in March last year. And we should have really been coming in April. But as we saw airports closing down and the globe basically going into lockdown, we're like, if we're going to be able to do this international move, we're going to have to go now. So we literally packed up our flats, our entire life in a matter of 4 days, and moved our tickets, or not even moved our tickets, we just bought new tickets and came over to join the Barnet community then. But living in a particular area in Israel, which is known for a particularly low uptake of vaccines and particularly vocal anti-vax movement, Nachlaot in central Jerusalem. They say that. Sorry?
Batayan or Nachlaot?
There you go. It was Nachlaot. Although it's not a particularly Haredi area. I mean, there are Haredi pockets there, but it's more the alternative area.
That's interesting. I had a friend who was really, really, really into the eco warrior stuff, like really into the eco warrior, like lived in Nachlaot, like crazy. Like, I don't use this, I don't use that. She had a dryer, and I was like, "You live in Israel and you have a dryer. Don't you start ecoing me."
So I think we probably confused a lot of people. Sorry, my internet connection is not great, but I think as a family we confused a lot of people because we very much I suppose in many senses looked and lived the more alternative lifestyle or hippie lifestyle. We had a vegetarian home, and our guests always said, well, why are you vegetarian? And maybe dressed a certain way and lived a certain way, and the tone of our home and our life was a certain way. People assumed that I was part of the enormous crowd there who didn't vaccinate, and always were surprised when I responded, no, of course I vaccinate, and I hope you vaccinate your children as well. Please don't come to my son's bris. If this was during the measles outbreak, there was a huge measles outbreak in Israel, and it's unfortunately also was one of the reasons why there was an outbreak here in London. I think, Ilana, correct me if I'm wrong, but they traced the measles outbreak in London to Stamford Hill, which had come over from Israel. So it was very unfortunate.
No. You were the one who called it, Shoshana. You were the one who called it. It was the people who went to Uman. They picked it up from Uman. Then they went to Israel. Then from Israel, they went to London and to New York. And you were the one who said it. I hope they don't bring back the measles. And it was you who, I remember you said it. You said, oh gosh, they're all going to Uman. I hope they didn't. And then they did. And it literally, you
So a lot of those travelers were our peers and our friends, and again there was a lot of shock when they found that we didn't quite fit the mold of what they assumed we were. But just so I just wanted to preface that this is not my halachic expertise. This is not my scientific expertise. But just in a nutshell, I wanted to present a couple of the major halachic considerations that come into vaccinating, and I'm really aware that we're running quite over time, so if I won't be offended if anyone does need to dip out. I'll just in a matter of 3 or 4 minutes. So there are two primary issues. There are two primary halachic implications And the first is that of protecting ourselves and our bodies. And we're given very strict guidelines that we are, as Jewish people, our bodies are holy, ourselves, we need to look after ourselves physically, and we're mandated to safeguard our bodies and our health. So we know that willful damage of our bodies is forbidden. And, you know, some people extend that to things like tattoos or self-flagellation or you know, body modifications that are not necessary or that are harmful. And this extends to also neglect of ourselves. So neglecting ourselves and our bodies is also considered, I guess, maybe not willful damage, but not safeguarding ourselves. So there's an issue when we fail to safeguard ourselves, to take all of the precautions that would keep us safe and healthy. And really, this boils down to an idea that personally I think is very beautiful, which is that we are a part of God. God created us of himself, and that we occupy these physical bodies that we've been given in order for a higher purpose of existence. That is to live the spiritual life that we are supposed to. And therefore, we need to safeguard our physical selves for the sake of that higher purpose. So really it boils down to for the sake of God as well. So I'm safeguarding myself for the sake of God. So that's the first idea. But the second principle is that of our duty to safeguard other people as well. So if it's within my power to protect another person from harm, well, then I'm urged to do so. And even if I'm not going to be the direct source of another person's harm, I'm still urged to protect another person from endangerment. And the primary example that the Torah gives is and quite famously, if someone builds a house and it has a flat roof, well then halachically, in terms of Jewish law, I need to erect a fence around that flat roof. Why? Because it poses a danger to another person. So I have to remove any possible danger to another person. Even if I'm not planning on going up to the roof and pushing them off, it's still within my remit to make sure that nobody can fall off. So that's our primary example of learning out that concept in Jewish law, but focused on removing impediments that endanger others. So another take on this same concept, I think, is correctly linked, is in the book of Vayikra in Leviticus. It says, don't stand by, don't be a passive watcher when you see someone's blood being spilled. So in the same way, the way that I think of this is the Good Samaritan Act. Like in some places, it's illegal to simply stand there if you see someone dying, if you have the skills to provide. I don't know, Joanne, is it right that you are medically trained? Is that? So am I correct that in some places it would be a criminal offense if you failed to provide medical care to someone who's experiencing a medical emergency?
I don't know about legal, but certainly against medical ethics to stand by while someone was in that situation, if you could act as well.
So it's the duty to assist, I suppose, the duty of care, duty to assist if someone were to, so in the same way that if someone's drowning, you extend an arm or a stick or throw the life buoy or whatever it is, that we have a halachic obligation to do so, to not stand by idly while someone's blood is being spilled, while someone's at danger or in peril. So I suppose, simply put, those are the two major halachic considerations to the questions of vaccination, is both the duty to myself, my own physical, safeguarding my own physical self, and that of safeguarding other people. And historically, and this is really interesting, rabbis have ruled on specifically on the incidence of a plague or an epidemic, and they've ruled that halachically, according to Jewish law, should there be a plague in a city, a person is halachically required to leave that city and to take his family with him. Oh, again, him, I'm using the gender, but a person, an individual, is required to leave that city and to take their family with them, to safeguard themselves and to safeguard others. So in a sense, I guess those, even 100 years ago, where the only recourse would have been to physically flee a place, nowadays we've been given another recourse, we've been given another course of action, and that's to kind of biologically flee. And I don't know if that's a correct way to put it, but to biologically run away from that source of danger, which is a vaccination. So this is how I would put it. I don't know if that's correct to say. And I suppose the principle itself is, again, to protect myself physically, to protect myself and to protect others. Now, of course, the flip side of that is that the vaccine needs to be safely tried and proven. Otherwise, I guess what we're doing is putting ourselves in harm's way. So we'd be doing the exact opposite. But again, this is where we need to turn to, we have to recognize the limitations of our own, and where rabbis have to recognize the limitations of their own knowledge, and recognize that their expertise is halacha, and their expertise is Torah, and their expertise is the incredible and wonderful areas of Judaism and religiosity and spirituality. But it's not necessarily medicine or science. And there are enormous numbers of rabbis who are incredibly well educated and have become incredibly well educated in science and medicine. But at the end of the day, we need to take our advice and we need to take our lead from genuine voices of expertise. So I just want to finish by saying that when I did a quick poll of friends and family over the last week, just saying, this is what I'm talking about, what would you say halachically is the what's the big deal? What's our big ticket for getting a vaccine? And the most common response was, well, doesn't it make sense in terms of ahavta l'reacha kamocha, that you should treat others as you treat yourself, or loving your fellow as you would love yourself? And that's kind of that golden rule, I think, really is the crux of the vaccination question, that if I am to extend to others the respect and the safety that I would expect to be extended to myself, just in terms of offering herd immunity, in terms of bringing a world back to a normalcy, bringing the world back to a place where people can function in a healthy, in a normative manner, well then surely there's at least something in that catch-all of the ahavta l'reacha kamocha, to treat others as you would want to be treated yourself, to extend to others the same. And Francesca is saying that just being a mensch, that's a halachic thing, right? And I suppose, yeah, we could sum it up in that one word, that it's being a mensch, to make sure that everybody around us is safe, to recognize to respect the authority of people who have knowledge that we don't, to have the humility to say, this is not my area of expertise, I'm willing to be led by other people, while I'm willing to be led by rabbis in certain areas, I'll be willing to be led by the scientific and medical communities, with obviously the input of rabbinic leadership, and again, sensible rabbinic leadership, which thank God we have, and to act according to that. So thank you, everybody. I 100% recognize just the struggles that we all face in keeping ourselves and our families and our children safe. And at the end of the day, and this might sound quite naff, but honestly, at the end of the day, it's all in God's hands. It really is. And I think the most important thing to do is to have a healthy attitude, to have a healthy outlook, and to pray to God that, please God, our families do remain safe. God, creates the plague, but God also creates the refuah. He creates he gives us doctors, and he gives us the know-how and the research and the brains that can do this, and he creates the antidote as well. So please God, we should all continue in health. Thank you, Ilana, very, very much for an incredibly enlightening and incredibly informative and incredibly professional presentation as well. So
about that. Thank you so much, Shoshana, for having me, and it was lovely meeting everybody. You're very welcome to ask me further questions. You can see my name on the thing, ilanaordman@gmail.com. So if you want to email me, it's IL, not two L's, ILANA at gmail.com. No space, no hashes, just one word. You're very welcome to, and I will try and my hardest, possibly next week when our year 11s have had their assessments written for them, because at the moment that is taking up a lot of my time.
And can I finish finally with a pitch for next week's, just checking that I've got the right one for next week, with next week's program, which is Let's Talk About Sex. We've got Dr. Hadassah Fromson joining us to how to speak to our children about sexuality and intimacy in a healthy way. So please join next week. Dr. Rebbitzin Hadassah Fromson. I don't know, Ilana, have you heard her before? You're saying goodbye. Yeah, of course.
Okay.
Is a Rebbitzin at Golders Green Synagogue. She also is a doctor of counseling psychology, and she did her PhD in sexual satisfaction in relationships. So it'll be really good to, she does a lot of teaching on how to interact with children, how to speak to children and teens about sexuality and intimacy in a healthy way, how to introduce them to concepts of intimacy and sexuality. So that's I think will be really, really interesting. So please join us next week. See you there. I'm going to stop the live stream here.
Just wanted to say thank you so much.
Yeah, thank you very much. It was really interesting.